In order to study biology, we need a sort of basic overview of chemistry. In order to be a good biologist, you need to know some chemistry and understand that chemistry in order to understand how molecules are put together, how larger structures like tissues and organs are put together. And so you need to know about different types of atoms, elements, the bonds between atoms to make compounds and molecules, and also how molecules interact with each other based on the different properties of the subatomic particles. This is an atom with protons, neutrons, and electrons, and the atom is the building blocks that are put together, stacked on top of each other, and interact with each other in order for living things to function. There is a cool little interactive activity through PBS Learning about atomic structure. And we're going to go through atomic structure, but it's kind of a nice way to review the material and have something interactive to work with in order to really understand atomic structure. In this picture that we saw earlier in the last module, this helps us realize that an atom is the thing that's important for building everything larger within living things. This is that building block that connects to other building blocks to create these large molecules. Atoms are building blocks of particular elements, and elements are the simplest form of matter. Can't break an element down into anything simpler. So, for example, carbon is an element. And if I had a lump of coal, carbon, in my hand, that lump of carbon would all be made up of the same type of atom. If I had a lump of gold in my hand, I could break it down into particles. I could break it down into atoms, but all of the atoms would be of the same type. There's only one type of atom in every sample of an element. There are 92 naturally occurring elements, and they're arranged in the periodic table. The periodic table organizes them on the basis of their atomic numbers, which is the number of protons, the electron configurations, and the chemical properties of these different atoms. In the periodic table, the elements are presented in order of increasing atomic number, and again, that's the number of protons. So I have one version of a periodic table here, which is a screenshot from an activity where you can go in and you can click on these different elements, and they give you information about the elements, which I just think is an interesting way to study the periodic table. But the periodic table has a couple of features that are most important to us, which is the atomic symbol, the symbol of the element, which is usually based on the name of the element. There are other elements that start with H, like, for example, helium. So the two atomic symbols here are different, but they're usually based on the name of the element or like a Latin name for the element. And here we have carbon, C, chlorine, Cl, different elements, different atomic symbols. And again, if I had atoms of this and atoms of this, so atoms of chlorine, atoms of carbon, the atoms would be different. They actually are made up of different numbers of subatomic particles, and subatomic particles are the protons, the neutrons, and electrons. Carbon, which has an atomic number of 6, has 6 protons in that building block type of atom. Chlorine has 17 protons. Now, another thing that's on this periodic table is the atomic weight. The atomic weight is going to be the number of protons and neutrons. And we'll review this again, but it's the number of protons plus the number of neutrons in an atom. And it's a decimal number here. It's not a whole number because we're going to find that there are different forms of atoms of the same element that differ in the number of neutrons. And so we'll see that the atomic weight can vary depending on the number of neutrons in an atom of the element. Atomic structure is what we're going to look at next.